Time travel has always fascinated humanity. It's a popular theme in science fiction. Philosophers also ponder its possibilities. The idea of journeying through time is intriguing, right? Imagine witnessing historical events firsthand, or consider glimpsing into the future. These possibilities fire up our imaginations. But can we truly travel through time? The concept of time travel raises many questions. Can we change the past? What are the implications of altering events? Could we create paradoxes? These questions delve into the very fabric of our understanding of reality. Neil deGrasse Tyson is a renowned astrophysicist. He's known for his ability to explain complex scientific ideas in a clear and engaging way. Tyson has written many books and hosted several science programs. He has become a prominent voice in science communication. Tyson's insights into time travel are particularly insightful. He draws upon his deep understanding of physics. He also considers the philosophical implications. His explanations are both informative and thought-provoking. Albert Einstein's theory of relativity revolutionized our understanding of time. His theory of general relativity proposes that space and time are interconnected. They form a four-dimensional continuum called spacetime. Massive objects like stars and planets warp this spacetime fabric. This warping is what we experience as gravity. Einstein's theory challenges our everyday perception of time as a constant. It suggests that time is relative. It can be influenced by gravity and motion. This concept is crucial for understanding the possibilities of time travel. Einstein's theory of special relativity introduces the concept of time dilation. This groundbreaking idea revolutionized our understanding of time and space, suggesting that time is not a constant but a variable that can be altered under certain conditions. Time dilation means that time can slow down or speed up depending on relative velocity. Essentially, the faster an object moves, the more pronounced the effect on time. This phenomenon is not just theoretical, it has practical implications and has been observed in various experiments. Imagine a clock moving at high speed relative to a stationary observer. To the observer, the moving clock appears to tick more slowly. This is because the high velocity affects the passage of time for the moving clock. The moving clock will tick slower than the stationary clock. This difference in the passage of time becomes more noticeable as the speed of the moving clock approaches the speed of light. This phenomenon has been experimentally verified. Scientists have conducted numerous experiments using highly precise atomic clocks placed on fast-moving aircraft and satellites. The results consistently show that the clocks on these high-speed vehicles tick more slowly compared to those on the ground. Time dilation suggests that traveling at speeds close to the speed of light could enable future time travel. If we could build spacecraft capable of such speeds, we might be able to send humans on journeys where they age much more slowly than people on Earth. As an object approaches the speed of light, time slows down for that object relative to a stationary observer. This means that for astronauts traveling at these incredible speeds, time would pass much more slowly compared to those remaining on Earth. This means astronauts traveling at such speeds would age slower than people on Earth. For example, a journey that seems to take a few years for the astronauts might correspond to many more years passing on Earth. They would effectively travel into the future. Upon returning to Earth, these astronauts would find that much more time has passed here than they experienced, making them time travelers in a very real sense. Section 5. Wormholes and Tipler cylinders. Theoretical bridges through time. While future time travel through time dilation is theoretically possible, traveling to the past poses greater challenges. Time dilation, a concept derived from Einstein's theory of relativity, suggests that as one approaches the speed of light, time slows down relative to an observer. This means that astronauts traveling at near light speeds could experience time at a slower rate compared to people on Earth, effectively allowing them to travel into the future. However, the idea of moving backward in time introduces a host of paradoxes and complications. Theoretical physicists have proposed several models to explore this possibility. These models often involve complex mathematics and advanced concepts in quantum mechanics and general relativity. The idea is to find a loophole in the fabric of spacetime that could permit backward time travel without violating the known laws of physics. Two such models are traversable wormholes and Tipler cylinders. These concepts, while still speculative, offer intriguing possibilities for how we might one day achieve time travel. Wormholes are hypothetical tunnels in spacetime, They are often depicted as shortcuts connecting two distant points in the universe, much like a tunnel through a mountain connects two separate valleys. They could connect distant points in space and time, potentially allowing for instantaneous travel across vast distances. This concept is not just a staple of science fiction, but also a serious subject of scientific inquiry. If traversable, wormholes might allow for backward time travel. This would involve entering one end of the wormhole and emerging at an earlier time from the other end, effectively moving backward in time. However, their existence and stability remain speculative. Theoretical models suggest that maintaining a stable wormhole would require exotic matter with negative energy density, something that has not yet been observed in nature. Another theoretical model is the Tipler cylinder. This concept, proposed by physicist Frank J. Tipler, involves a massive, infinitely long spinning cylinder. This model involves a dense, infinitely long spinning cylinder. The idea is that the rotation of this cylinder could create a frame-dragging effect, warping spacetime around it. Its rotation could warp spacetime, creating closed time-like curves. These curves are paths in spacetime that loop back on themselves, theoretically allowing for backward time travel. These curves might allow for backward time travel. However, the practical challenges of constructing such a cylinder, not to mention the requirement for it to be infinitely long, make this model highly impractical with our current technology. However, constructing such a cylinder is beyond our current technological capabilities. The energy requirements and materials needed to build an infinitely long, dense, spinning cylinder are far beyond what we can achieve today. Despite these challenges, the study of these theoretical models continues to push the boundaries of our understanding of the universe and the possibilities of time travel. Section 6. Carlo Rovelli. Is time merely an illusion? Theoretical physicist Carlo Rovelli offers a different perspective on time. He suggests that time might be an illusion. Rovelli proposes that our reality is a complex network of events. We impose a sequence of past, present, and future onto this network. This view challenges the traditional linear progression of time. It raises profound questions about the nature of reality and our perception of it. Rovelli's ideas add another layer of complexity to the discussion of time travel. Section 7. Neil deGrasse. Tyson's skepticism. Navigating the paradoxes of time travel. Despite the intriguing theoretical possibilities, Neil deGrasse Tyson remains skeptical about traveling to the past. He often discusses the complexities and challenges that come with the concept of time travel. While the idea fascinates many, Tyson emphasizes the importance of understanding the scientific principles that govern our universe. He believes that without a solid foundation in these principles, the notion of time travel remains speculative at best. He points out the potential paradoxes and inconsistencies. These paradoxes, often highlighted in science fiction, pose significant challenges to the feasibility of time travel. For instance, the famous grandfather paradox questions what would happen if a time traveler were to prevent their own grandparents from meeting. Such scenarios create logical inconsistencies that are difficult to resolve within our current understanding of physics. For example, what happens if you travel back in time and prevent your own birth? This paradox, known as the self-consistency principle, suggests that any actions taken by a time traveler in the past must be consistent with the timeline they originated from. If not, it could lead to a contradiction where the time traveler never existed to travel back in time in the first place. Such paradoxes raise fundamental questions about causality and the nature of time itself. The concept of causality, which states that cause precedes effect, is a cornerstone of our understanding of the universe. Time travel, especially to the past, challenges this principle by suggesting that effects could precede their causes, leading to a breakdown in the logical structure of events. Tyson aligns with other physicists like Stephen Hawking, who believe that future discoveries might reveal laws preventing backward time travel. Hawking proposed the chronology protection conjecture, which suggests that the laws of physics may prevent time travel on macroscopic scales, thereby protecting the timeline from paradoxes. He acknowledges the allure of time travel but emphasizes the need for scientific rigor in evaluating its feasibility. While the idea captivates the imagination, Tyson insists that any serious consideration of time travel must be grounded in empirical evidence and a thorough understanding of the underlying physical laws. Only then can we hope to unravel the mysteries of time and explore the true possibilities of traveling through it. Section 8. The allure and limits of time travel. A balancing act. Time travel continues to captivate our imaginations. It allows us to explore the boundaries of our understanding of the universe. The possibilities of witnessing historical events or glimpsing into the future are undeniably appealing. However, we must balance this allure with the limitations of our current scientific understanding. While future time travel through time dilation seems plausible, backward time travel remains highly speculative. Section 9, Conclusion, Time Travel, an Enduring Mystery. The exploration of time travel is a journey into the unknown. It pushes the boundaries of physics and philosophy. While the possibility of traveling through time remains an open question, it is a testament to human curiosity and our desire to unravel the mysteries of the universe. As our knowledge expands, we may one day unlock the secrets of time travel. Until then, it will continue to inspire our imaginations and fuel our quest for understanding the cosmos.